Hi, I'm Oliver Spasovsky, a senior 3D character artist with over 10 years of experience in creating captivating characters, creatures, and environments for both games and films. I've had the privilege of working on exciting projects, including the casting of Frank Stone in Judas, and have contributed to high-profile game studios and cinematic productions. Today, I'm excited to share with you insights into the world of digital art and how it bridges the gap between game art and cinematics. Digital art has transformed how we create for the entertainment industry. From the early days of 2D pixel art to today's highly detailed 3D assets, it has become the backbone of both games and cinematic production. Whether it's crafting immersive worlds or designing characters, digital art plays a key role in every step of the creative process. In this video, I'll be guiding you through the fundamentals of digital art, with a focus on how it impacts both game art and cinematic visuals. To bring our ideas to life, we rely on powerful software tools. For 2D work, we often use Photoshop and Krita, while for 3D assets, programs like ZBrush, Maya, and Blender are essential. When working in games, we optimize for real-time performance using engines like Unreal or Unity. For cinematic productions, more complex rendering is possible using software like Houdini or Maya, allowing us to focus on the finest details. In both cases, tools and techniques must adapt to different workflows. Optimization for real-time in games, and high-detail rendering for pre-rendered cinematics. In digital art, both 2D and 3D play crucial roles. 2D is key in the early stages. Concept art defines the style and design of characters, environments, and objects. It's also vital for texturing and UI elements. On the other hand, 3D art is where those concepts take form, becoming fully realized models and environments. In games, assets need to be optimized with lower poly counts for real-time performance, while cinematics can afford highly detailed models. Texture maps like normal, roughness, and metalness maps bring these models to life, helping create depth and realism. Character design is about storytelling. We begin with concept art, imagining what the character represents and how they fit into the world. In 3D, we sculpt the characters, carefully balancing detail and efficiency. Game characters need to perform in real time, while cinematic characters can push for greater realism. Once modeled, characters are rigged for animation, and then textured using tools like Substance Painter, Mari, or Marmoset Toolbag. The final step is applying shaders to bring out their realistic qualities. For cinematics, this can include more complex techniques, such as subsurface scattering to simulate skin. Creating immersive worlds is crucial for both games and cinematics. Game environments are designed to be fully explorable, with assets reused and optimized for performance. In contrast, cinematic environments are often one-time use and built for specific scenes or camera angles. Procedural tools like Houdini can help generate large landscapes quickly for both mediums, while modular design in games allows for flexibility. Optimization techniques such as occlusion culling and baked lighting ensure games run smoothly, while cinematics prioritize high-quality visuals at the expense of real-time performance. Lighting is one of the most important aspects of creating atmosphere. In games, we use real-time lighting optimized for performance, often with techniques like baked lighting to save on resources. Cinematics, however, allow for fully dynamic lighting setups, including advanced techniques like global illumination and ray tracing. Texturing is also key. Physically based rendering, or PBR, allows for realistic materials in both mediums, but with different levels of detail. In games, we often use texture atlases to optimize memory usage, while in cinematics, textures can be more specialized. Animation breathes life into our creations. Keyframe animation is widely used, but motion capture has become increasingly popular for creating lifelike movements. In games, animations must adapt to real-time gameplay, using techniques like inverse kinematics and blend trees to adjust dynamically. Cinematics, on the other hand, allow for more polished, predetermined animations. Real-time engines like Unreal and Unity are crucial for game animation, while cinematic projects may rely on offline rendering tools like Maya for smoother, more detailed motion. Rendering is where everything comes together. In games, we rely on real-time engines like Unreal and Unity, which handle all elements, models, textures, lighting, and animation on the fly. Optimizing for real-time performance is crucial, with techniques like level of detail, LOD, and deferred rendering. In cinematic productions, however, we use offline renderers like Arnold or V-Ray, which allow for incredibly detailed images but take much longer to process. The differences in rendering techniques show how the same digital assets can serve very different purposes. As technology continues to evolve, the gap between game art and cinematics is narrowing. With real-time engines like Unreal 5 pushing the limits of what's possible in games, we're seeing higher fidelity than ever before. Tools like AI are also making their way into digital art, helping automate tasks like texturing and animation. Virtual production is another exciting trend, blending game engine technology with live-action filming. The future of digital art promises to be more dynamic, immersive, and creative than ever. Thanks for watching. I hope this gave you a clearer view of digital art in both games and cinematics. The creative journey never stops, so keep pushing boundaries and bringing your visions to life. Until next time, stay inspired and keep creating.